Hi, my name is Mason Krasinski and I am a part of the CLEVERarm team trying to solve the problem of stroke rehabilitation in the United States. As the semester closes, my team consisting of myself, Dawson Fields, Jillian Gakusen, Paco Santi, and Savannah Yu have been working toward creating and integrating a VR therapy game to the CLEVERarm exoskeleton, as well as finding new ways to control the machine. Currently, strokes are the leading cause of serious long-term disability in the United States. An estimated 795,000 people suffer from a stroke each year, with 600,000 of those suffering from their first attack and 195,000 suffering from recurrent attacks. With there being not enough practitioners to fulfill the traditional one-on-one therapy and the average yearly cost of treatment being about $12,000, not enough stroke victims are receiving the care that they need. To meet the growing demand, an alternative solution besides one-on-one rehab sessions with therapists is needed. To do this, we decided to make an exoskeleton that gently removes a patient's arm. The patient will be hooked up to the CLEVERarm system, a machine that helps guide a patient through movements that help rebuild the connection between their brain and their arm. During therapy sessions, having a goal helps a patient focus on their movements, so we chose to create a game to help focus their attention on a common goal: to cook a homemade meal. In order to connect the CLEVERarm to the game, a TCP/IP connection had to be established between LabVIEW and Unity. LabVIEW gathers the information sent by the compact Rio from the encoder at the joints of the arm. This data collected with complex math allows us to display the position and rotational quantities that will be set to Unity to control the game. Unlike a typical session, the patient will interact with the game environment through the use of the CLEVERarm and by following specific instructions from the game. Moreover, since we are adjusting the needs of a therapy session, we designed the recipes in a way such that the patient performs repetitive exercises in order for the patient to regain their sensory stimuli. For example, the patient will be instructed to reach over and pick up an egg and drop it into the pan 3 times before progressing to the next instruction. Then, the patient will be instructed to do the stirring motion for a certain period of time before continuing. These repetitive exercises in an immersive virtual environment will not only achieve the goals of a therapy session, but will also make the sessions more engaging and useful for the patients as they try to do these simple tasks in an entertaining environment. As we approach the end of another semester, the proposed solution seems very feasible. While we've made significant progress in scanning EMG signals, we have also been fully able to integrate our VR rehabilitation games to the exoskeleton. With a bit more time and study, I could see our solution being completed very soon in the near future.